Hello everyone, and welcome back to On the Spot STEM. Today we'll be doing 2012 AIME II number 14. And the AOP solution to this used a lot of casework, and it wasn't like an unfathomable amount of casework, but you had a bunch of cases, and computing each case wasn't very simple either. But when I was doing this problem, I found a much nicer recursion based solution, and so I'm going to show you how that works. So the problem reads, in a group of 9 people, each person shakes hands with exactly 2 of the other people from the group. Let n be the number of ways this handshaking can occur. Consider 2 handshaking arrangements different if and only if at least 2 people who shake hands under one arrangement do not shake hands under the other arrangement. Find the remainder when n is divided by 1,000. So, essentially what this problem is asking us to compute is the number of ways we can have such that each person shakes hands twice with someone else inside this group. So, if we had 4 people over here, then person 4 can shake with person 3, he can shake with person 1, and he'll have his 2 handshakes then. So 3 and 1 each have 1 handshake now. Now 1 can shake with 2, and then 2 can shake with 3. And in this scenario, all 4 people have exactly 2 handshakes each. So we can quickly see that not all combinations are doable. For example, if 4 shakes with 3, and then 3 shakes with 1, and then 1 shakes with 3, these 3 people each have 2 handshakes each, but person 2 can't shake with anyone without destroying the rule. And then person 2 doesn't obey the rule, him or herself either, so we can't do anything there. So we have to find the number of ways that it satisfies this within this 9 people. So let's just look at what the last person can do first. It doesn't really matter what the order of these handshakes are, because the end result, we just want the end result to be the same either way. So, let's just assume the last person shakes first with someone. So this 9th person can shake with anyone from these first 8 people. But let's just assume that he shakes with person 8 and person 7. And we'll multiply this by 8 choose 2 at the end. Because there's 2 ways to choose from 8 people. Now let's just look at what person 8 does. He already has 1 handshake. So he can shake with one person from 1 through 7. So if he shakes with person 7, then 7, 8, 9 are satisfied now. Because essentially 8 shook with 7, 8 shook with 9, so that's twice. And then 7 shook twice and 9 shook twice. Now we just have the case of the first 6 people where no one shook. So it's equal to first 6 people. But if person 8 doesn't shake with person 7, if he shakes with someone in this first 6, I'll just assume he shakes with person 6 and I'll multiply by 6 later. Then the number of ways that this can happen is, now that 8 is satisfied, we essentially have a state of 7 people. We have a state of 7 people with last two with 1 shake. Right? Because these last 2 people over here, they only have 1 shake remaining since they shook with someone else outside of this sort of bubble. So we want to find a way to maybe relate these 2 values together, or we want to find a way to create a function that can model this scenario. So we identified our 2 states as when the first few people did not shake at all with anyone yet, or when the first few people had the last 2 people in this group already have 1 shake left, or 1 shake remaining only. And so these are our only 2 states actually, because if you observe, when you have n people who have not shaken with anyone yet, so essentially our blank slate, no matter who this last person shakes with, we'll always have a state of n minus 1 people with these 2 people with 1 shake each. It doesn't really matter which 2 people, but we'll have 2 people in this group of n minus 1 with exactly 1 shake each. And if we have a state where these 2 people have 1 shake each, then we're never going to have a state where more than 2 people in the first few have 1 shake each. So what I mean by this is that this 8th person, if he shakes with person 7, then we'll have a scenario where we only care about the first 6 people now, where no one's shaken with each other. If he shakes with someone else from the first 6, then person 8 is satisfied, so we can remove him off the bubble. And now we only have a state of 7 people where the last 2 people have 1 shake remaining. So these are our only 2 states. And essentially all we have to do is come up with functions for them now. So I'm going to call f of n. So f of n, then this is equal to the number of ways that n people can shake hands, assuming no one shook yet, and satisfies the problem constraints, of course. So what we're trying to find is f of 9, because that's when we have 9 people and no one has shook yet. And I'll call our other state g of n. This is equal to the number of ways that n people can shake hands if the last 2 people only have 1 shake remaining. And as we saw here, g of 8 is essentially the state when these 2 people shake with person 9. So this state over here is essentially g of 8, because out of these 8 people, the last 2 only have 1 shake remaining with some of these other 8 people. So now we want to find a way to relate f of n and g of n together, maybe through an equation or something. So let's call f of n. Let's just see what happens when we have this state. So this last person, since it's all empty, he shakes with any of these n-1 people. He chooses 2 people to shake with. And after that, we're in a state where n-1 people are there, and the last 2 people only have 1 shake remaining. And if person 9 shakes with like 1 and 2, we can always just reorder these people such that 1 and 2 go in the last 2 positions. It doesn't really matter. But the point is that we'll have 2 people we have 2 people in the set of n-1 people that have 1 shake remaining. So it's equal to n-1 choose 2 times g of n-1. Now what is g of n equal to? Well, when we have these n people over here, say n equals 8 over here, so this person shook with person 9 and this person shook with person 9. So these guys have 1 shake remaining. They can either shake with each other and then they'll be satisfied. So if they shake with each other, which happens in one way, then we have n-2 people left because 2 people are now satisfied. So it's equal to 1 times f of n-2, because none of these n-2 people have shaken with anyone yet, and that's consistent with our definition. If he doesn't shake with this second to last person, and instead someone in the first n-2, there's n-2 ways to do that. So let's just assume he shakes with this last person here. And what's our new state? Well, person 8 is now satisfied, so we can chop him off the bubble. And now we have a state of 7 people where these last 2 people only have 1 shake remaining and they shook with an outsider. So this is the state of g of n-1. Because we have n-1 people remaining, we have 7 people left from 8, and these 2 people only have 1 shake left. So this is just it. This is just our 2 equations that we need. Now all we have to do is fill them up in a table. And as you can see, these equations are fairly simple, so computing won't take that long. So I'll make a table over here and we can fill it up. Okay, so we have a table with n rows and we'll have 2 columns. This left column will be f of n, and this right column will be g of n. And we'll label the columns from 1 to 9. So first we'll have to work this table from bottom down, or from top down, or essentially it's bottom up, since we go from the simplest subproblems to the hardest problems, the hardest subproblems. And this is because f of n and g of n both rely on previous states, so it would make sense to calculate the previous states before calculating the next successive ones. So let's just compute these. And we can't really rely on our formulas for f of 1 or f of 2 or g of 1 or g of 2, just because of the way we have n-1 and n-2. But fortunately, computing these is very simple, since it's just what happens when we have 1 people or 2 people. If we have 1 person, there's no ways to make it so that this person shakes twice, because there's only 1 person. And g of 1 is also 0, because this person can't, there's no state where where the last 2 people in this set of 1 person has 1 shake remaining, because 2 is greater than 1. Now f of 2 is also equal to 0, because if we only have 2 people, they can't shake twice, right? So that has to be 0. And g of 2 is 1, because when we have 2 people, if they already shook once with someone else, they'll have to shake together, and that only happens in one possible way. So now we can use our formula for the rest of these. So f of 3 is equal to 3 minus 1, choose 2, which is equal to 2, choose 2, times g of 2. That's equal to 1. Because g of n minus 1 when n equals 3 is 1, times 2, choose 2 is just 1. Now g of 3 is equal to 1 times f of 3 minus 2, which is 1 times f of 1, plus 1 times g of 2, because n minus 2 is 1 and n minus 1 is 2. G of 2 is 1, so g of 2 is 1 times 1 is 1, and then f of 1 is 0 times 1 is 0, so g of 3 is equal to 1. Now f of 4 is equal to 3 choose 2 times g of 3, which is 3. And then g of 4 is equal to f of 2 plus 2 times g of 3. So that's equal to f of 2 plus 2 times g of 3, which is equal to 2. So now f of 5 is equal to 4 choose 2 times g of 4, which is equal to 6 times 2, which is 12. And g of 5 is equal to f of 3 plus 3 times g of 4. So 1 plus 3 times 2 is 7. F of 6 is equal to 5 choose 2 times 7, which is 70. G of 6 is equal to f of 4 plus 4 times g of 5. So that's equal to 3 plus 28, which is 31. Now f of 7 is equal to 6 choose 2 times g of 6. And that's equal to 465, since it's 15 times 31. G of 7 is equal to f of 5, which is 12, plus 5 times g of 6. So that's equal to 167 when you do the math. And then f of 8 is equal to 7 choose 2 times g of 7. So that's equal to 21 times 167. And you're not supposed to use a calculator on AIME, but I'm just going to use that because it's simpler. So 21 times 167 is 3507, so that remainder is essentially 507. But since we care only about mod 1000, and then g of 8 is equal to f of 6 plus 6 times g of 7. So 70 plus 6 times 167 is equal to 1072, I believe. Yeah, so that's 072. We just put 72 since it's mod 1000. And then now f of 9, which what we actually want to compute, is equal to 8 choose 2 times g of 8, which is times 72. This is equal to 28 times 72. That's equal to 2016. Of course, this is mod 1000, so we just take 016. We put 016 here. The remainder when n divided by 1000 is thus 016, and we're done. So thank you for watching. If you enjoyed this video, please subscribe and tell your friends and family about this. And AMC season is coming up, so we also have a bunch of other videos on our channel that are relating to AMC or AIME problems. So go watch those too. Thank you.